Okay, welcome. In this video we're going to take a look at how to create a spline sampler script operator. This can of course be done with some of the standard operators already built into TP, but we just want to use this as an example of how to use the recalculate outputs function that we looked at in the TP iterator example. So we're going to go ahead and start off. We will open up our we've got a directory here on the DVD called Assets Script Operators Template. We'll pull in the ScriptOp template, and we're going to go ahead and just replace the name like we normally do. We're going to call this SplineSamplerTutorial, and we'll just do a replace all. And then of course we also need to update and generate a new class ID for this. And we will also modify the category to be M3D tutorial. Okay, so anytime we're going to have a kind of an iterator style script operator that deals with recalculate outputs function, we're going to want to set up a local variable. We're going to call this outNum, and we're going to initialize that at -1. And this is kind of a control mechanism that's going to be set up down here in TP calculate, where well, we'll get to that. Yeah, it's going to test it, and then it's going to jump into a separate loop and then recall this TP calculate using the recalculate outputs function. But we'll get into that in just a second. We need to set up a spinner, since we are going to have a world step size for this. And just a kind of a big picture overview, we're going to take the length of the spline, we're going to have a spinner to define a world kind of step size in max units, and then we're going to divide this length of the spline divided by that step size to get a certain number of points, or total number of steps, along this spline to kind of interpolate the position at. So let's go ahead and jump back into our rollout. Let's just pull this down, drop in a spinner. I know nobody uses the visual editor anymore, but I do. So we've got step size, and we're actually going to call that step size underscore spin. We're going to set this up with a minimum value. Yeah, you know, 1's pretty good, but a maximum value, we'll set it really big, and then a default starting value of 10. Okay, so here's our spinner, and you remember with TP operators, anytime that we modify a parameter and then we go off and do something else and come back to that operator, that value is still what we set it to last time. And the reason this works is because all of the rollout parameters also have a parameter defined, and these are the actual at least from what I understand, you can look at the scripted plugin clause. This is what actually stores the values and ties it to the UI item. So we're going to have something also called step size spin, and its type is going to be a float, and it is going to be bound to the UI item called step size spin. So we're going to have that. This color type is fine. Our input, we don't actually want it to be a particle, we want that to be a node, and we are going to call that the curve. And then our output is actually not going to be a float, it's going to be a position, or multiple positions. And because it's multiple positions and we're going to be using an iterator style output, we're going to use the asterisk in order to indicate that multiple values can be coming out. This will be called the position. Okay, so let's just go ahead and evaluate this for the moment, get that out there. We are going to need a node in order to pick our spline, and then we're going to go ahead and grab the M3D tutorials, SplineSamplerTutorials right here. For some reason that step size is showing up as 1. That's not what we were hoping for. And okay, and so then it's going to output a whole bunch of positions for us. Let's go ahead and get into that. You remember with the TP iterator example provided by Cebus, and using this outNum kind of as a control mechanism. The way we're going to set this up, we're actually going to take out this portion of this template script, and what we're going to do is once we're inside this TP out ID test, meaning if the TP out ID is actually being requested, then we're going to test if the out num is greater than, well, in this case we'll just test if it's greater than -1, then we'll do something else inside here, else we'll return undefined. And what we're going to do, if the out num is greater than -1, then we're going to do a case of the TP out ID of, and what this does is says in the event that the out ID being requested is 0, which is this number here for the position, then what we're going to do is we're going to output, you know, whatever, and in our case it's going to be a position value. We actually need to set up a local variable to handle this too, so let's go ahead and add that. Actually, we're going to need a few local variables. We're going to need one called, let's see, we're going to have out position, and that's going to start off undefined. But before that, technically, we're going to have one called the curve, which is going to be our input curve, and that'll be undefined. And then we'll also create one for total steps, even though we may not need that. But okay, so we've got our little out num check is set up here. If it's greater than -1, which is its default value, then it's going to go into the out IDs and output whatever value. And in our case, we're going to set up this out position to be this guy right here. So we'll just put out position as our output for 0. Okay. Let's evaluate, make sure we're still kosher. Okay, so now what we're going to do is we're going to come down in here into the else clause, because remember this is where the recalculate outputs is going to occur. Basically what's going to happen is we're going to enter a loop where we start to increment our out num, and as we increment that out num, then we're going to call recalculate outputs, and that's going to bring us back into this TP calculate function. The out ID is going to be tested greater than or equal to 0, and out num is actually going to evaluate true here, and so it will output that value for that current loop down here from the else clause. So it's a little bit to get your head around, or maybe not. So what we're going to do is actually we're going to set up we're going to specify and assign our variable the curve to be equal to TP in out get in value 0, which of course is going to bind that to the input coming from here. It would be good and proper to put a little test in here to make sure that this is actually a spline, but we're going to skip that for now. So we've got the curve being defined as that in value, and then we're also going to set up a variable for step size, and that's simply going to equal our step size SPN parameter up here. Okay, so then let's do a little check. We want to make sure that the curve is not undefined, because if it's undefined, then we're not going to have anything to evaluate. So if the curve is not undefined, then go ahead and proceed into this loop. And inside this loop, we want to do a couple things. We want to we'll create a new variable called outCurveLength, which is just going to be the curve length of the curve. And then what we're going to do is actually we're going to calculate, or we're going to look at the step size value that the user has on the spinner, and we're going to calculate how many steps we're going to need along this spline. But what we need to do is we need to actually check if that step size is greater than the entire length of the curve. So we'll do a little test here first. We'll say if step size is greater than outCurveLength, then we're going to assign our variable total steps to be equal to 1. Else total steps is going to be equal to our out curve length divided by our step size. Okay, so now our total steps, we've got that value. It's either going to be 1 if the step size is too big, or it's going to actually give us a number of our length divided by the step size. So we've got the total number of steps. We can now say for I equals 0 to total steps, do the following. And here in the following is where we are going to do this. First, we're going to set up a new variable called thisStep, which is going to be a return a float value between 0 and 1, telling us, hey, my current step along this spline, meaning this step, is going to be equal to it's going to be I as a float divided by total steps. Okay, so that's going to be that specific step value. Let's put a little comment in here. Returns 0 to 1. And what we're going to want to do also is we're going to want to go ahead and increment our out number. So we'll just go ahead and set it to I plus 1. So remember, I started at 0, so immediately it's going to go up to 1, and then our outnum requirement here, once we need the output, that will be satisfied now. So outnum is going to be equal to that, and then lastly we're going to go ahead and actually calculate that position. So we'll say outposts equals, let's go ahead and just grab the MaxScript function from there. That is going to be length interpolate. The curve is our shape. Curve number is optional, we don't need that. And steps is optional, so the parameter is our 0 to 1 value that's required, and that will simply be this step. And then we need to go ahead and call the TP in out recalculate outputs. Okay. And that's almost it, because what's going to happen at this point is for the total number of steps from 0 to whatever that total number is, we're going to calculate that percentage from 0 to 1. We're going to increment our out number just to get it above -1, and then we're going to go ahead and calculate that position from 0 to 1 along that spline length, and then we're going to go ahead and call the TP recalculate outputs. And what that's going to do is, while it's inside this loop, it's then going to bring us out and back into the TP calculate function, and that's then going to test and say, hey, yes, I've got some out IDs connected, but then at this point it's going to say my out number is actually larger than -1, so we can go ahead and output if the, in this case, the out position. It's going to say, because if you have multiple outputs, you know, you could output other things like out alignment, or whether or not the position, the step that you're on, is a starting position or not, or starting or ending position. So those are, you can set up all different kinds of outputs based on whatever parameters that we want to calculate. Okay, so it runs through, it's inside this loop. The recalculate outputs is bringing us out and then back in, but then we need to do a little housekeeping, and once we're outside of that loop, we actually want to set out number back to a -1 value, and then we also want to go ahead and return true. So we'll go ahead and update that. Let's delete what we had, bring in a new one, connect it right away, and we'll go ahead and use a position born, and we'll connect this output position. You see that position data type goes right there. We're going to generate 1 per call, which is going to be required whenever we have that kind of iterator style output. The speed we're going to set to 0, and the alignment variation to be 0. So if we start to modify our step size, you can see a smaller step size is going to mean a smaller distance along that spline, means that the total number of steps is going to increase. And if we increase that step size, that's like increasing our world raster, we'll obviously create fewer steps and more distance there. So okay, so let's go ahead and save this script. Save as under TP script operators video examples. This will be TP SplineSamplerTutorial.ms. Okay, so this is kind of the basics of using and implementing that recalculate outputs functionality. So if you need multiple outputs per output ID, not just multiple different connections, but actually from this one specific output ID, you want multiple outputs. That's when we're going to need to use that recalculate outputs function. The way that we structure that is we set up a local variable to initialize at -1, and then what we do is we test inside our TP calculate function if the out IDs are actually connected, and if the out number is greater than 1, then we go ahead and output those values. But of course this out number is only going to be greater than -1 after we've skipped through this step the first time, when the value is still -1. We get into this else clause, and then here in the else clause is where we do kind of all the calculating for those parameters, or values. We do whatever calculations we need to iteratively to calculate whatever we're after. And so then once we get into this loop, we set up that loop to determine how many times we want to iterate, and then we, at the bottom of that loop, well, first we also increase that out number so that it will actually satisfy this true function and come into this output phase. But then here at the end, we go ahead and we call that TP recalculate outputs function, and that's going to actually, while we're in this loop for X number of times, it's going to be bringing us back out, bringing us into the TP calculate. The out ID is going to evaluate true because something's actually connected, and then the out number now, because we increased it, it's actually going to be above -1. So this function is going to go ahead and output whatever value we've set up here on that output. And then, of course, that's only for one iteration, from I equals 0 to how many ever times. And so then it's going to come back, it's going to update, well, we're still inside this loop, and so it's going to keep calling that recalculate outputs while it's in this loop, bring us back into the this out num evaluates true, and then our case out ID, and then we output those values. Sorry, that's kind of a long, redundant verbalization of that description, but that is kind of how it works. So if you have any specific questions, go ahead and shoot me an email or see you on the forum. So SplineSamplerTutorial, what it does, we'll just fill this in. Whoops, positions. Okay. We'll save that and let's go see what's next.